All right, we're in section 11.5 where we are going to choose the best model for uh, two-dimensional data. Okay, so what this is really similar to being able to find uh, essentially kind of like the line to fit, but the only difference is we're not dealing with just a linear equation. We can look at quadratic equations, we can look at cubic equations, we can look at exponential equations or functions, whatever, however you want to call it. And basically what happens is we are going to look at the data on a graphing calculator and then manipulate the graphing calculator to give us the unknowns to be able to write the equations. So what we're going to do is there are different ways on doing this. Uh, in this particular lesson, I'm just going to show you how to use it on a TI-84 graphing calculator like this right here. Okay, so uh, we have the aspires in class. I'm more than happy to show you what those is when we actually use those aspires, but for right now, we'll use the TI-84s in this particular one. TI-83s would work as well. So what we're going to do is we have our piece of data. So we have our x values 1, 2, 3, 4, 5, 6, 7, and we got our y values 30,000, 624, or so on and so forth. So what we got to do is we got to put that data into the graphing calculator. So what we're going to do is you are going to click on the stat icon right there, and we're going to edit. So if there were data here, you would have to hit delete here to get rid of the data, but and since we don't have any, we're all good to go. So I'm going to start filling in L1. L1 is going to be our X value. So I got 1, 2, 3, 4, 5, 6, and 7. So now I'm going to go onto the L2s, and that is going to be our Y values in this case. So now I got, what, 30,624. We got 32,436. We got 34,167. We got 35,989. We got 37,684. We got 39,311. And we got 41,098. All right, so we got all our data into the stat um, edit. So I'm going to hit second quit. I'm going to quit that. Then what we're going to do here is I want to hit start plot. So second, why I want to get my start plot, what I want to do is I want to take this plot 1 here and I want to turn it on. So we're going to turn it on here. So it'll be what, hit enter. So I got it on. I want the type to be the dots here, and then these dashes are fine as well. So now what we're going to do is we're going to click on window, and I want to use my window to be able to read this. So, my smallest x value was 1, so I'm just going to make my smallest x value here be like 0. My largest x value is 10, that's fine. Increments of 1, that's fine. Well, my smallest y value in this case is like 30,000, so I'm just going to say 30,000 in this case. And then my largest y value is like 41,000, so I'm going to say like 42,000. And then I'm going to put it into like increments of, let's just say like 100. And go from there. So I'm going to go second quit there. So now I'm going to graph it. So this is the points that I get from the data. Now we have to make a decision. I feel that looks really pretty much resembles a line. So I'm going to say that this looks like a line right here. So because it looks like a line, I'm going to use the linear equation y equals mx plus b. So what that means is in our calculator, what we're going to do is you're going to go second quit, you're going to go back to stats, and you're now going to go to calculate, and you're going to go down to, in this case, since it's a linear equation that we're going to look for, I'm going to look for a linear equation. So I got my linear equation, ax plus b, so that's the y equals mx plus b, sort of speaking. And then they want you to say, okay, I'm going to use L1, so second L1, if you notice it right here, comma, second L2. So this is just telling you that using the X and Y values from the stats that we just plugged in, we're going to hit um, we're going to hit enter. And so what that did was is it created values for A and it created values for B. So if you look here, A is 1,738.89 and B is 28,945.7, 1. So my equation is going to be y equals, you know, 1738.89x plus 28,945.7. And that's my equation. Okay, let's go to the next one. So here it says we have these kinds of stats here. So again, I'm just going to clear this. Let's go back to, whoops, let's go back to stat. We're going to go to edit. I'm going to delete the stuff that I just created in L1 and L2, and we'll get whole new data. So now I got, what, 0, 5, 10, 15, 20. All right, and then I go to my Y value, which is 500, 729, 1271, 2206, 3765. All right, so now I got my stats. My plot should already be on. I got to pick new windows. So 0, that seems fine. Um, I'll go to like 25 increments of 1. That's fine. My minimum was, let's see, my smallest number was 500, so I'll say let's go 400. And then my largest number, we'll just say 4,000. Keep it in increments of 100, sure. And well, yeah, that should be fine. Well, let's see what that graph looks like. So now if you look at this graph here, it kind of looks like an exponential function. If you look on this page here, this is what an exponential function kind of looks like, and it kind of resembles that. Let's see here. So I am going to say that this is exponential. So since it's exponential, we're going to use y equals a times b raised to the x power. So now I'm going to go back here, second quit, go back to stat, go to calculate. I want to go find that in this calculation. So I have exponential regression, which is what we're looking for. So I hit enter. Now I go to L1, comma, L2, hit enter. And so now I have values for A and values for B. So now my equation is going to be y equals 467.9 times it by B, which is 1.11 raised to the x power. So now looking at This example here, again, plugging in these values, going back to the graphing calculator. I'll clear that. Go back to stat, go to edit, delete all these. All right, so start with our x values. So I got 0, enter, 2, enter, 4, enter, 6, enter, 8, enter, 10, enter, 12. Go to the y values. I got 85, 163, 282, 341, 398. I got 381, 304. All right, so I'm going to go my window. So smallest value is x. You can kind of leave it like that. That's fine. My largest value for x is, so we'll just call it 15. My smallest value for y is 85. I'll just put 50. My largest value looks like it's so close to 400, so I'm going to say what, 415. I'll say it's in increments of 25. I'll go there. So when I graph this, it looks something kind of like this. So it looks like, it kind of goes up and then it goes down. So it kind of resembles like a parabola. Parabola where, the value of a is negative. So if you recall from anything we dealt with parabolas, with the upside down U shape that look like this, a was going to be a negative value. So I'm guessing that this resembles, a parabola. So that means that our equation is going to be quadratic. So it's going to be y equals ax squared plus bx plus c. And we know because it's upside down, we know that this one's going to be a negative value. So plugging this in, second quit, go to stat, let's calculate it. Let's try to find quadratic. So it looks like it's right here. So now I go L1, comma, L2, hit enter. And so now we got values of A, B, and C. So now my equation is going to be, let's see if I can move this over. Y equals negative 4.34x squared plus 73.7x plus looks like 62.76. And that would be my equation for that. And so basically what I want you to take from this is, you're going to look at, different types of general equations. So, this was both of these values here and here are exponential functions. It's general equations, y equals a times b raised to the x power. Quadratics, the parabolas, y equals ax squared plus bx plus c. We're all pretty familiar with linear equations. It's a line, whether it's positive or negative. The power equation is just being able to figure out how many exponents you need. And remember that you got your cubic equations could possibly look like this, or it could possibly look like that, depending on, um, you know, depending on the data. So a lot of it is being able to take your own interpretations of the data and use that to your advantage to be able to find the correct equations. Okay, I do have in the notes how to make a scatter plot from the TI inspired calculators that are in class. Um, if people need a separate video on that, I'm more than happy to do so. I just won't be able to show it to you because I don't have those capabilities to be able to see it, unlike what I have right here. And that is how we choose the best model for two variable data. I hope this helps. Until next time.